Good morning, everyone. I hope everyone is having a wonderful Saturday morning. And my name Good morning, Good morning, everyone. I hope everyone is having a wonderful Saturday morning. And my name is Dr. Roy Carter, and I'm here to present you with the last and final geoscience teacher training and in preparation for the CSTEM Challenge, which is next month. And so I hope everyone is excited about the CSTEM Challenge as much as I am. I'm looking very much forward to all of the teams and their presentations on the Geoscience Challenge, and looking forward to just seeing like all of the great work. I have a lot of faith. I've been to a number of these challenges, and I've been very impressed with the quality of work that's come out of the teams and of the kids. So, with that said, let's move on to where we should be whole CSTEM challenge. So, of course, we're towards the end, and so right now, all of the teams should have settled on a solution. Then they should be finalizing that solution, and they should be preparing their solution and also preparing to present. So, one of the things that we're going to go over today is I'm going to give you some tips on how to present and how to make an effective presentation in order to effectively persuade the judges that your solution is the correct one, or is the winning one, I should say. So, as we all know, as we've been going over this for the last 6 months, the Geoscience Challenge this year is concerning pipelines. And so what we were looking at throughout this whole year is that the American Society of Civil Engineers, they put out an infrastructure report card, and their report card gave the oil pipeline infrastructure within the United States in a poor to fair condition, with most of it below standard and a lot of the elements approaching the end of the service life. And so also what we discussed in previous teacher trainings is that a large portion of the system exhibited significant deterioration, and that the condition and capacity are of significant concern, which with a strong risk of failure. So, what we are asking all of the teams to do for this geoscience challenge is we're asking them to create a functional geoscience model that demonstrates how improvements to the energy infrastructure will make it more reliable and sustainable in your region to improve your grade on the ASE report card. So basically what we're trying to do is ask all of the teams to put together some type of solution. You need to identify a portion or a problem, just a small portion or problem with the pipeline infrastructure, and then what would your solution do in order to solve that problem? So therefore, you don't have to necessarily. We're not trying to boil the ocean here. You don't have to design a brand new pipeline. We're just asking for a very focused and targeted solution to a very focused and targeted problem. And so, what we're asking all of the teams to do is submit their geoscience solutions on basically you need to create no on the, excuse me, you need to draw it out on an 8.5 by 11 inch graph paper. And then also we're going to ask all the teams to put together some type of like if well let me put it like this: if your solution requires some type of physical solution, let's say it's a pig, for example, we're going to ask that all the teams put together like some type of model that represents the type of pig that they're proposing as a solution. And also, with the last but not least, and also one of the most important things is that we're asking all of the teams to put together a 5 minute presentation to discuss why your solution, what it is about your solution, and just present that to the judges. So just to review the previous geoscience trainings, by now, hopefully everybody has had a chance to go back and review all of the teacher trainings that have happened, and they started back in October. And if not, I highly, highly, highly recommend that you do that, especially if you have any questions. Because we started off with the system kickoff about what is geoscience. We talked about the different career options within geoscience. And then we went into the teacher training one, which is introduce the pipeline CSTEM challenge, geoscience challenge, which is about pipelines. And then we went an overview of pipelines. Then we moved on in the second teacher training to the basically the challenges that are facing an aging pipeline infrastructure. And then in teacher training three, I gave you a couple of potential solutions for this CSTEM geoscience challenge. And the fourth one was how to create a solution. This is how to basically we tried to introduce the creative process to you so that you be able to teach your children the best way to go about creating a solution, how to make a prototype. Then, last but not least, we ended up with the overview of the overall creative process because, as you probably have figured out now, the C-STEM challenge really is not really concerned with having a right answer. It's really this whole process has been about trying to get kids to become creative because that's really the how to become a good engineer. A good engineer is a creative person, somebody that can think outside the box. And so that's what this geoscience challenge has been trying to get your kids to do is basically think outside the box, think like an engineer would think. So one of the things that I said is that we are going to require all of the teams to present their findings. Now, before I begin and try to get and then give you some tips on how to present your findings, one of the things I want to stress to all of your to all of my teachers that are listening to me now is that, and also all of the students, is that effective communication is probably one of the hardest things that you can do, but also one of the most important skills that you can have. If you can effectively communicate your ideas to people who do not know what you're talking about, you will go a very long way in life. As I work here, I work at Chevron, and then I see people who are exceptionally smart, but who do not know how to present, do not know how to effectively communicate, do not know how to talk to people. And those people, they do have a hard time climbing the corporate ladder. Whereas people who don't necessarily know what they're talking about, but they can effectively communicate, they tend to get advanced. So this is a really vital skill that you can have. So one of the things that I'm going to do in the next couple slides is just talk about some different types of ways that you can go about presenting your findings to the judges. And so let's look at the first bullet, which is just remember it's only 5 minutes. So the presentation is only 5 minutes. So therefore, please don't stress. Tell your kids not to stress about the presentation. It's only 5 minutes. And so therefore, and really 5 minutes goes by very quickly. So one of the things that we're emphasizing is that you shouldn't have that many slides. You should have a 1 to 2 slides maximum. And the trick with presenting slides like this is you want to simplify the slides. So try to keep them as simple as possible. Less is more. Okay, the one of the things that I'm going to, the next slide, we're going to talk about an executive summary format. And then this is a format that I use if I'm going to present to, let's say, the VP of my business unit. As you can see, he's really busy. He's consistently busy. So you need to give him a format that will deliver a lot of information to him, but at the same time, so it has to be substantial and it has to be correct. But at the same time, it has to be simple enough that he can basically consume it in one slide. And then also another idea that you can have in terms of simplifying your slides is try to go for, as maybe try to tempt like going high level. So pictures, drawings, if possible. And so that'll help to illustrate the concept that you're trying to pass on to the audience and judges. But one of the things that I would say is be careful about putting too many words on the slide. Like sometimes you can have it wordy, but be very careful. Don't just put a lot of words on a slide and then just read directly from the slide. People tend to get bored that way and tend to lose interest. So that's why I say if you have some pictures, some drawings, something that can kind of like make your slides pop, that tends to draw a lot of interest in your slides. And so this is like a sample executive summary slide. And so as you see, we have four main sections here, and it's in a table format. So you have a problem statement, and then the problem statement is basically you're just describing a high level overview of the problem. And so, as I said before, try to keep it simple, try to keep it easy to understand. And then the challenge is why is this problem important? So provide a couple of bullets explaining why the judges should care about this problem. And so questions under consideration. So this is you're describing your research. You're describing what questions were asked and how what questions were answered and what questions does this solution actually attempt to solve. And so last but not least, then you go into the potential benefits. So what benefits could be potentially achieved by adoption of your solution? And then also, as you can see, there could be a potential a lot of overlap. between especially like the potential benefits, the challenges. So therefore, feel free to, this is just a sample. Feel free to make it your own in terms of an executive summary. This is that also you can go through and Google executive summaries. There's a lot of good samples on the web too. But this is just one way that I use in order to deliver like a lot of information quickly to to very very busy people, or get your point across very quickly. And then, so these are more tips on how to present your findings. So, if possible, let the judges interact with your solution. So, if you have a physical solution or physical model, I should say. So, for example, a pig, bring it down to the judges. Let your judges kind of like touch it. This helps better engage the judges and establishes rapport. And then one of the things we can also discuss is also design. Be beware of using, because a lot of times I see, especially with when younger kids try to present, is that they'll try to use these really fancy templates. And the problem with these really fancy templates is that they can be very difficult to read. And so one of the things, especially if you're using dark letters on a dark background, that's very difficult for judges to read. And so try to keep your design template very easy to read. And then remember is that if you're not enthusiastic about your solution, if you have a projection that you really could care less about your solution, then why do you think the judges should care about your solution? So therefore, try to be enthusiastic about your solution and say, hey guys, this is what we did. Be enthusiastic, be confident in your presentation, and people will be confident in your solution too. And then last but not least, make sure to practice. Definitely do 2 to 3 dry runs before the actual presentation. Go through, figure out who's going to speak, how they're going to speak, how they're going to go through the presentation, and definitely do 2 to 3 dry runs. Don't go in there, as we call it, cold. Now, with that said, last but not least, as I've said before throughout this uh, the entire teacher training. If you have any questions, feel free to contact me. I'll hang around for another. Believe we have about like 13 to 14 minutes left, and I'll hang around here. And if you have any questions, feel free to ask me, or feel free to contact me at roycarter@chevron.com. And then, last but not least, I want to thank everyone for their participation in the CSTEM challenge. I'm looking forward to hearing all of your great solutions to the geoscience challenge, and I've been just very fortunate to work with all of you. So I wish all of you well, wish all of you safe travels down here to Houston, and hopefully you have a great rest of your day. Take care and bye bye. Hello and welcome to our last presentation, teacher training for everyone's an artist and engineer, 2014-2015 energy infrastructure, wind, oil, and natural gas, VEX robotics teacher training, elementary level. Today's March 28th, 2015. I'm your instructor, again, Felipe Resendez. And according to our academic year pacing guide, this workshop is to finalize an artifact solution. Students will finalize their CSTEM challenge project solution and prepare to compete. So basically what I wanted to talk about today is competition day. For most of y'all at this point, you are either finishing or wrapping up your robot for programming, but there's a lot more than just finishing up there at school. There's a lot of stuff that you guys need to keep in mind while you go to competition. Our training outline for today, very simple and very brief. Project scheduling for competitions, ideation and design, build and integrate, testing, and competition preparation. We're going to go through the first three bullets here relatively quickly, and then I'll be giving you ideas. A lot of the stuff might overlap with something you might have already done today to this point, but I just wanted to give you the whole spectrum of what we've been doing here in the last couple of weeks. Project plan preparing for competition. Project scheduling for competition varies based on the size of the team, the complexity of the competition, and the sources available to the team. All projects can be broken into multiple stages. And like it says here, depending on your team, your members might be doing all these different phases of preparation and planning for the actual competition day. The bigger the group, the easier it gets to actually assign and allocate responsibilities. A little harder for you as an instructor to keep track of who actually is responsible for what as the competition progresses. Background research, define the problem. Where are the competition objectives? By now, you should have already read the rules and hashed out all the possible alternatives to how you're going to score points and be successful and hopefully winning every match. Identify team resources. What do you have available? Do you have spare parts? Do you have an extra motor? Do you have? You want to be able to have the critical elements and parts mapped out in case anything happens when you're in the field. What are your strengths? Do you focus your strong points to and make them work to your advantage? Do you have very good drivers? Do you have people that can program and do something totally off the beaten path and maybe give you that advantage during competition? So those are some of the things you need to focus on. And of course, your weaknesses. What are you going to try to avoid while you are doing competition or while you are preparing your robot? Have you scouted your competition? That's another good question. I mean, what are they good at? Maybe you can pair up with someone that might give you a better balance through for this competition. And I guess, and again, recruit talent as you progress through the years and through actually even the competition. It's always good to have someone available that might even a last minute entry might be good at maybe power tools, etc. Scheduling, identifying key dates, mandatory meetings, competition day. And this is more for like the structure of your organization while you're actually going through the process. When you're going to meet after school, during lunch, or in the mornings. Make sure all the critical mandatory trainings, or if there's a kickoff party, make sure they're all there. Like for example, this Saturday, this meeting. Select team roles. These can change. You might get someone that gets assigned a role of lead team manager, but then due to his schedule, all of a sudden he's not available. So you might want to have to reassign someone for that specific task. Maybe a programmer, have a couple of them, have redundancy in this case when you're there. And another one is identify adult mentors who will work with each team. This is a must to help you during competition. So parents can help you. I've had some very good parents for mentors that can also add to your expertise and knowledge. And yet I've had some parents that have been counterproductive. I have had parents fight with the actual judges during competition, which I have very little control over. I would say to please, go take a seat or leave the competition. So there's just some examples that have happened to me in the past with parents, but they're a very good resource. You cannot keep an eye on everybody during competition. It's great to at least have your mandated mentors per students. Concept development. How will I play the game? What is your area? Strategy. What is your robot and team members capable of doing? Again, this is kind of like a strategy. Which sensors will you be using?
If you're using any sensors, I mean, how are they programmed? Where are you going to program into? What's the easiest way to trigger a sensor or a button that's going to, launch that application or that particular movement of the robot? What types of activating mechanisms do you need to deploy or launch part of a robot first before everything is starting to actually work? Where are they programmed again to? What buttons? Practice, I guess this case is, make sure you know your buttons, you know where everything's at, and you're actually getting some good repetitions. What type of mechanical mechanism? Do you have any pulleys, sprockets, or motors are going to be maneuvering? Keep that in mind. Prototype, all of you should already build a prototype at this point. You should already be talking to me with almost a finished robot, something like it's on the picture down here. You want to be testing your ideas. You should be fine-tuning your robot at this time and not making big drastic changes like frames or major components like removing wheels and having to take everything apart. Test sensor feasibility. Are they working correctly? Do you have it programmed, for example, a sound range sensor? Does it do what it actually tells you to do? Does it react fast enough? Those are some of the things you need to be working with at this point in the prototype stage. Preliminary design review. Review game rules. Again, have the whole team go over the rules to maximize points during competition. It would be a good idea to actually strategize this particular, have a session just for this. And how are you guys going to stick to your guns? How are you guys going to be focusing on during competition? What are you going to be focusing on during competition? Excuse me. Present game concepts to team. Make the whole team aware of what your strategy is going to be during the gameplay. Again, what's going to happen the last 10 seconds of a play? Is there a particular position you need to be at, or for example, be holding something with your robot for the last couple of seconds? Again, that's all goes back to game planning and reviewing the game rules. Review the schedule. Go over your assigned time to keep an eye on the field of play. You could be missing an opportunity. Assign someone to be in charge of keeping track of the field of play. In the past, we were so busy repairing some issues with a robot that we actually had to. We were on the last calling queue for our next match. We had to forfeit one match in order to be able to finish and compete successfully. I mean, there's some of the things you guys need to consider. Assign someone that's going to keep an eye on the field, and when your time is up, and give you an estimate of time. Hey, we got 5 minutes, guys, at most, and very key person to have. Assign deliverables. Don't assign yourself the task of doing everything. Give everyone responsibility. Who's loading the robot in parts? Who's going to be carrying it to the field? Who will be your safety manager? Another key. Keep your area clean. Very important. You don't want to have people to get cut or hurt doing the robotics. I know there's not a lot of stuff, but you will be using probably power tools or sharp edges. Keep your area clean. Keep the drinks off the table. Keep food and drinks definitely. It's a no-no. Try to have a designated area for that or a certain time. Building robots. If you have this capability, you might want to build a second robot, or maybe the foundation or base of another one, that in case something happens, a critical element in your robot, you might be able to swap it out pretty quickly. Not everyone has this opportunity, but as you invest in the program and obtain more equipment, consider having 2 robots or critical components. Test new parts. If you add new parts to your robot during competition or here in the last couple of days, make sure you test and have enough time to do so. I've had where students change the light before certain mechanisms and throw everything off. And next thing you know, certain functions are not working on the robot. So make sure you are testing as you go along and everything works effectively. Keep design simple and robust. Typically, a simple robot can actually win you the match. They don't tend to break during the competition as much. So keep that in mind and keep it as simple as possible if you can, and to maximize efficiency on the field of play. Programming. Review motion requirements. Are your buttons programmed effectively? Are they doing what you want them to do? That's the key. Hey, I press B, but it goes forward, and then you have an issue. So make sure you're addressing all these little minors and checklists. Identify and test multiple strategies. You might want to have a backup plan. Maybe you change your focus during competition and say, you know what? If I reload my revision 2, I'll be able to get this done. So maybe at the next match, you might be able to run that particular set of code. Save backups of all programs, very important. Keep a flash drive handy, not only just your laptop. We've had issues where our laptops have failed. We had to reinstall the actual programs, and we had to recode every single line of code in the past. So that's due to the fact that we didn't have a flash drive handy. We relied only on the laptop. Something happened to the laptop or the charger, and we ended up not being able to pull our current software. So keep that in mind. Keep it on an external device, and begin testing with time. Test and compile your code and run the robot each time you make any changes. Detailed design review. Review final design, go over the last minute changes again. You might want to also review game strategy for one last time. See if there are any new rules that have recently changed. Sometimes the competitions change the last minute when they work out the kinks and update their gameplay. And again, review programming, go over the code, make sure everything's written correctly, and comment it as much as possible so it can make it easier to just modify on the fly. And review research possibilities. If you're not capable of achieving the target, you would like to spend some time with your students to learn about a certain sensor, a certain strategy, or have an opportunity where you ask probably a competition team, hey, I'm sorry, I've wanted to do this. How did you achieve this goal? And trust me, kids will pick it up really quick, probably faster than you will, and they'll be able to maybe apply it in the next competition. And very good learning opportunity, not just competing. Try to make it a friendly environment and an education environment as you head on to this competition. One of the last phases here is called testing. Allow as much time for testing as possible. Critical to work out the bugs. This is the key. Make sure you are working out the bugs. If it's not working properly, try to get some help with experience, maybe another team member or an association you have with another robotics teammates, or even another teacher from a different location, system staff. There's a lot of stuff on VEX on forums and websites, and there's always a lot of friendly people out there ready to help and give you a hand. Begin to test using game conditions if possible. That's the actual field. It always helps when you are actually practicing with the actual environments. Maybe replicate a part of the field that you're going to be focusing on. That gives kids an opportunity to practice their skills and movement and how the robot reacts. We had times where we that same day we're practicing, bam, you finish the robot, the coding, and we are on the deck and trying to figure out what's going on. So by the time 2 or 3 matches go by, we could have scored a lot more points. So try to actually, if you don't have that opportunity of replicating the field, arrive early. Typically, a lot of these competitions allow you to practice a little bit beforehand, at least to test some of the kinks out. Use fresh batteries. I cannot express this enough. We've had robots just die halfway to competition. If there's a backup battery that you can install, which I know you can, make sure you have the 9-volt battery sticked in there. It actually helped us save one event where we were so close that we ended up winning that match because our backup battery kicked in, and we were able to finish the actual competition on time, and we will advance to the next level, to the final round. So keep that in mind, very handy. Keep them charged, get a multimeter, test them to make sure they're within the right voltage range. If it is, typically that means that it's charged to the 7.2 volt or higher. Directions and time. Make sure everyone has a copy of directions to the venue or location. Print and email copies and pass out the night before or at your last meeting. Give your cell phone number to members and mentors, especially adult mentors. Make sure that you have everyone's number. All the consent forms are done, that you've done all the necessary paperwork to come to the competition. The last thing we want you to do is not get in trouble for coming to compete to such a great event. And in the past, I would give my cell phone numbers to everyone. Hey, if you need to leave, your parents come pick you up, you let me know. I need to, make sure that's your parent and sign you off. A lot of times these competitions tend to take a little bit longer. I know some of you will be traveling from far, so that's not an issue. But always keep that in mind. Maybe their parents want to tour the town with you and stuff. Since you're in Houston, there's a lot of things to see. Make sure you actually, you know the parent and they're signing off with you. Make sure everyone on the team knows the time of the event. Go over the logistics of who's driving, who's going to be driving with who. And also the meeting, what time you're going to be lunch. Are they going to be serving lunch, or are you guys going to be going out to eat? All the little details that, it may sound these are just small, insignificant details, but they do make a big difference to getting the whole group in and out and getting everyone safe to competition. And at the very end, I always leave time for cleaning and packing. In the past, everybody leaves, and technically the teacher and is the one that's ends up packing a lot of the stuff and trying to get the team ahead. I would usually, there towards the end, I will assign a mentor, a couple of people. Hey, this is our last round or two. Start packing up, cleaning the tables, making sure we're leaving everything the same way as we received it. Programming and hardware, bring extra copies again, use a flash drive, make backups of your programs as a refresher, as a review. Make sure your team members are prepared to discuss their software and hardware design. This is very critical. You might have cameras coming up to you. Make sure you have some people that can actually talk about the robot and your design and your approach, your strategy. Make sure you can answer questions for judges and stuff like this if they're going to be judging on your robot. Bring extra batteries. That's definitely a good point. Bring spare parts as you're using the robot. Have the spare batteries charged and swap them out. You know, every 2 matches or so, or every match, swap out a battery. Bring spare parts, sensors, and wires in case they break or your team decides to change the design. Very important. Make sure you have all this handy. A quick tip on this. We used to buy some little Stanley compartment dividers. I know Vex has a lot of parts, but we used to carry these little like toolkits, and we would divide them inside. Then put all the bolts, the nuts, wires, motors are separate on these little kits, and we can just fold them up and unfold them as we go along, and just use them and then throw stuff back in there. And I would label some of the little boxes just to make sure everybody knew where everything went. Finally, research your presentation. Be sure that each person on the research presentation team has an alternate. If you're going to present, if you're going to talk about this robot, make sure you have that person rehearse and review, not just the main person, but a backup. We had an issue where a student once was in another part of a VEX competition, not C-STEM, but he was in another competition at the same time. He was presenting something and had to do with a driver's meeting, you know, a mandatory driver's meeting, and we were actually on deck presenting, and his part was pretty much. Was done on the fly, and trust me, judges can know this. So make sure you have people that can back each other up on your strategy as well. Schedule elementals to listen to your presentation before you get to the competition is always a good idea. If you're presenting or to have your mentors actually listen in, at least rehearse once, so you can have a better feel of what you need to do and what you need to work on. And again, practice your presentation and make sure that all the technology works. And guys, thank you. I know this is a very brief and very just general idea. I just wanted to give you some tips and things of what to do on competition day. Make sure you register if there's a registration tables, and sign in and get your robot inspected. If there's an inspection, there's just some of the things, and they vary by competition, like I said. But this is just a general ideas that they're out there. Go ahead and have fun at this point. Don't stress out. You've made it this far. Go out there and have fun and try your very best. Remember, don't forget to calendar our competition April 18th. Any questions, email me or call the system office at 713-443-4521, or email me at philipperesenda00@gmail.com. Thank you. Welcome to Everyone's an Artist and Engineer 2014-2015 Energy Infrastructure, Wind, Oil, and Natural Gas, VEX Robotics Teacher Training, Middle and High School. Today is March 28th, 2015, and this is our last training of the actual competition season. I'm your instructor, Felipe Resendez. According to our academic year pacing guide, today's workshop is to finalize an artifact solution. Students will finalize their CSTEM challenge project solution and prepare to compete. My focus of this competition, especially for those new teachers that have never been to a competition before, just to kind of give you some tips and hints of what to expect during competition, just generalization of the event. Our project today, project scheduling for competition, ideation and design, build and integrate, test, competition preparation. And these are the four general ideas that we've actually been working with the last couple of weeks, but it's just kind of like a summary of everything that's been happening, and I'll be giving you some tips for future and actually for the upcoming competition. And finally, I'm going to go over some bonus troubleshooting guidelines for the general robot, VEX key, and motor key for you upper level middle school and high school. Project planning, preparing for competition. Project scheduling for competition varies based on the size of the team, the complexity of the competition, and the resources available to the team. All projects must be broken up into multiple stages in order to be successful. And again, if you have a 5-man team, very different than a team that has 20, kids, 40. You might have to be a little creative on assigning rules, responsibilities, and roles, or else the kids will get frustrated or wander off, and they will not get engaged as much as possible. So try to keep them engaged during the whole process, if all possible. And even during competition, assign who's going to be responsible for the robot, who taking it to the field, coming back, security, keeping an eye on the pit, or who's going to keep an eye on different things. Background research, define the problem. What are the competition objectives? By now, you should already read the rules and then gone through most of the parameters of this competition. Identify your resources. What do you have available? This is your first year, and you're basically very limited. Do you have a multimeter or any other special equipment that might help you out to debugging code? If you do, if you don't, identify team strength. Focus on your strong points and try to make them work to your advantage. What is your team good at? Do you have inexperienced programmers? Well, maybe you want to make something robust and something sturdy that's going to get through. Do you need help with do you need help with programming? That could be a weakness. Maybe you want to call out and maybe go to some forums or associate yourself with another team that might have a little bit more experienced programmers and stuff. And again, recruit talent. It doesn't matter. I've recruited kids like the week before. Hey, we have a competition. Come out there, come see it, and they've been hooked for the rest of the upcoming seasons and stuff for the year and future competitions. Scheduling, identify key dates. Make sure what are the mandatory meetings for your organization. When are you guys meeting every day? Competition, and this goes back a little bit further prior to maybe starting to this whole process. But this is just kind of like a quick overview. Select team roles. Assign programmers. Assign who's going to be working with the drivetrain. Assign who's going to be working with the electrical and wiring. Who's going to be doing the talking and presentation. Who's going to be, if there's a presentation involved, who are the members on the presentation? Stuff like this. Identify adult mentors who are willing to work. Make out a schedule and talk to your mentors. Very important. They can also give you a different approach and angle. During competition, they are the most precious things you can actually count for, because they can give you a quick break. Maybe you have to sit down and eat something. You'll be surprised that you get so caught up with keeping an eye on everybody in the competition and trying to solve problems that you forget to eat sometimes or drink. Keep mentors around. Make sure they are with with different people. Maybe they're presenting. You got to have a mentor there. So and you can't be in two places at once. So make sure you have the school allowed mentor per student ratio and all your forms and stuff ready to go. Concept development. How will you play the game? What is your team strategy? And I apologize, I had a little mistake there. What is your robot and team members capable of doing? Which sensors are you using? Are you going to be developing a robot based on sensors? Where are they programmed to? These kind of questions that you need to start developing and coming up with. What types of activating mechanisms? Do you have any mechanisms that need to deploy when the company, first thing before the robot gets going? in order to meet the parameters of requirements. In other VEX competitions, we have to fit within a certain dimension of a box. And then if you wanted to deploy the robot afterwards, it would actually work. I mean, so what are some of those, again, going back to the rules and strategies of the game? What types of mechanical mechanisms do you have? Are there any pulleys, sprockets, motors? I mean, what are you doing? Is everything done according to the VEX instructions? Prototyping, you should already be done with this at this point. You should already have this prototype ready to go and testing out ideas. You should be fine-tuning actually your robot at this time, and hopefully working all your kinks with the sensors and make sure the robot is doing exactly what you are telling it to do. If you're not at this point, it would be a good idea to maybe tweak the sensors or maybe look for replacing a sensor or two. Preliminary design review game rules. Again, have the whole team go over the rules to maximize points during competition. I cannot tell you, I've had drivers that never bothered to read the rules, or were in the meetings where we had the rules, and when the game starts, it's my turn to drive. They had no clue of how to actually score them or maximize their time on the field and score the maximum possible points. So go through the rules, do's and don'ts. What gets you disqualified? What gets you points taken off, etc. Go through all that. Present game concept to team. Make sure the whole team's aware of the strategies they're going to do during the gameplay, like I just mentioned before. For example, if there's the last 10 seconds of the game, maybe you have to go and pick something up and make sure it's on a certain level and put it there, and that'll give you maximum points. And make sure you're achieving those goals as you planned. Review schedule. Go over the assigned times and keep an eye on the field of play. You could be missing an opportunity. Assign someone to be in charge of keeping track of the field of play. Very important. In the past, we've had to actually forfeit a round just so we could be ready for the next round. We had some major issues with the motor. We had to take it apart, and by the time we only had about 10 minutes in between, so we had to forfeit a round for the sake of the whole competition, and we ended up doing a lot better once we removed the motor. So keep someone assign someone for that. Very important. At least they can tell you, hey, we're on cue, we're ready to go. We have to be on the starting block here in the next couple of minutes. Assign deliverers. Don't assign yourself the task of doing everything. Make sure you're assigning your students responsibilities of who's loading the robot, who's taking care of the tools, who's in charge of motors or electrical, who's in charge of taking the robot to the field, who's picking it up, who's doing the actual cleanup there towards the end and loading everything to the truck. All these could be safely assigned and so you won't have to be doing everything there towards the end. Build robots. If you have this capability, it's always good to have a backup. Not everyone has this opportunity, but as you invest in the program and obtain more equipment, consider having 2 robots or critical components done. If, say, for example, you have an arm and you know that there's an issue with a sprocket, make sure you have the little arm partly set up or have the sprocket handy and ready to swap out in the event that something goes wrong. These pulleys or sprockets do tend to break, so keep that in mind. Keep design simple and robust. An effective robot can win you a match. Build a robust robot if all possible. This is very key to any competition. Too much complexity, then you lose track of where the ports go, electrical, and all that kind of stuff. But it can actually help you out if you keep it simple and everything labeled. Programming. Review motion requirements. Make sure the buttons are doing what they're supposed to be doing. Identify and test multiple strategies. Do you have a backup plan? Say, for example, on one match, you want to try to go and reach a certain level. Well, you might have to program the robot a different way. So have these pre-programmed code ready to roll and upload during your time off between matches. Keep that handy. Save all backups of all programs. Keep a copy of the flash drive where you, in case your laptop fails. That happened to us before. I think someone dropped the actual power converter and pretty much ran out of battery about halfway during the competition, and we didn't have our code. We had to go grab a new laptop, load the program, and redo the code from scratch. So it would have helped if we had the copy of the flash drive with us. We'd be able to just save some time. So begin testing at this point. When you compile code, run each robot each time and make sure it's actually doing what it's supposed to be doing. Detailed design review. Review the final design. Go over last minute changes you might want to do with the robot. Try to keep them as simple as possible. Don't make drastic changes. Review game strategy. What is the best approach to win the competition? Again, if you decide to make a big change there towards the end, everything falls apart. Try to just keep minimal changes there, and review how are you going to approach this competition with your current robot. Review programming again. Once again, this is critical. Go over the code, make sure it's correctly written and effectively commented, so that way you know that this is working. Review research responsibilities. If you're not capable of achieving a target, you might like to spend some time learning about a new sensor or a new strategy. I've actually gone up to other teams and say, hey, listen, we've always wanted to do this particular type of setup you have here. Can you explain to us what are you doing? How does it work? And let me tell you, kids on the other teams will jump to the occasion to actually present and how they approach this. So, and let me tell you, your kids will probably learn it faster than you would, because they'll probably be able to pick it up quicker and be able to probably apply it at another competition, or maybe in the future the next year's event. So use it as a training opportunity, learning opportunity. Testing, allow as much time as possible for testing. At this point, you've already done your prototype test. I cannot tell you, test your robot, make sure it's working. You don't want to over test. You don't want to damage components. Keep an eye on those kids that want to press the button so hard that next thing you know, the arm is going 200 miles an hour the opposite direction, and next thing you know, you're asking, why doesn't it work, when all the gears have actually just stripped. So test, but do it diligently and be responsible of how the test is being done. If possible, test using actual field parts or replicas of the field. You might have to arrive early the day of competition. If you do not have a replica, you want to at least have a good feel of the field, and if they allow you to, your robot, how is it going to participate during competition? Very key thing to do. We in the past, we've actually replicated almost half of the fields in other VEX robotics competitions, and others that we are basically running the robot the minute that we are on the actual there at the starting line. So very frustrating, very nerve-wracking. You want to practice as much as possible to get all the kinks away. Use fresh batteries, have them on hand, swap them out if you have extra batteries, keep recharging them, have someone in charge of swapping and changing the batteries. You might want to take a multimeter to make sure that they're completely charged. It's always good to do a voltmeter test. Directions and time. Make sure everyone has a copy of directions to the venue and location. Print an email and pass them out if you can. Give your cell phone number to adult members, adult mentors, and some of your key personnel members that you know you must have on hand, like your programmers, certain drivers, or important people that are going to be there for the event. Or the person who has the robot that might want to take it home the night before to do some last minute changes, and he has not shown up, and everybody's there at the rendezvous point, but you're a robot and you're main programmer. I talk by experience. Make sure everyone on the team knows the time of the event to go over the logistics of who's driving, what time are you guys eating, what time we're wrapping it up, what time it might be, where you're going to meet, and all this kind of stuff. Once again, programming and hardware, bring extra copies of the software. If you have, bring the software with you to reinstall on another laptop, and bring a backup of your programs in a flash drive. Make sure your team members are prepared to discuss their software or hardware changes at this time. If there's any judging going along and you want to discuss the software or what your approach and to the judges, it's a good time to have someone and ready to do this. And again, bring extra batteries, extra parts, sensors, wires in case they break and your team decides to make any last minute changes. It's always good to be prepared in the event that something goes wrong. Research presentation. Be sure that each person on your research presentation team has an alternate. If you have to present your robot or any strategies to the event, and I'm just talking generalities here, you have to assign multiple people who can talk about your robot or that particular section they're in charge of. We had an occasion where our main presenter was part of the driving team, and they are assigned presentation actually overlapped another event, so we had to wing it. And trust me, the person that we put in last minute didn't know half of the stuff that he was supposed to say, so needless to say, we didn't do as good as we wanted to in that particular VEX competition. But again, this is all dependent on the game and the field, so read your rules. Schedule adult mentors to listen to your presentation before you get to the competition. If you can, rehearse it right before and then go out there. Practice your presentation and make sure all technology works. Bonus slides, guys. I've actually downloaded this particular setup here for you guys that are middle school and high school. If you're having issues with the actual troubleshooting, here's a flow chart of what you need to do. And it's very simple. It tells you start. Does the Cortex turn on? Yes, no. If it says yes, is the robot LED on the Cortex consistently red? If you say yes, okay, is the robot LED blinking? Yes, no. And just follow it through. Is it blinking fast or slow? Well, it's doing slow. Single or double blink? Well, I think it's single. Programming error. Try switching to default code and you found within your programming software. So I'm not going to go through the whole thing, but I'm showcasing here what you can do and actually go through it. There are bonus slides for general troubleshooting and also for the different events here. Troubleshooting flowchart. Do both units turn on? Yes or no? Does the joystick LED red? Yes. Okay, and just keep going through, and this will give you a good idea of what to do in the event that you fall into some trouble. The last slide that I have here, motor troubleshooting. Does your motor spin? Yes, no. Are you using controller 29 modules on all the 2-wire motors? Are you using your controllers, motor controllers? Maybe you forgot, or maybe the motor controller burned out. So this gives you a good idea if it tells you how to troubleshoot. I mean, it's not the end all be all, but it gives you a good solid understanding of what might be the problem. It kind of helps you narrow your focus of attention. So with this said, I just want to wish you all the best of luck, and thank you for putting up with me all this year in the last couple of trainings. Don't forget to mark your calendar the competition day, and at this point, have fun. Go out there, enjoy. Don't get too stressed out. Enjoy the system competition. It's awesome, and hope you guys all do very well and keep improving. Don't get discouraged. Improve and get better every year. Any questions? Email me or call the system office at 713-443-4521, or you can email me at feliperesendez00@gmail.com. Thank you and good luck.
Hello everyone and welcome to the 3D printing Saturday workshop for March 28th. This is the final Saturday workshop. As you can see here, we are in cycle 7, and at this point students will finalize their System Challenge project solutions and prepare to complete, prepare to compete. At this point you're pretty much finalizing your 3D print design. That means you're no longer going back and deciding, okay, what should my 3D print design be. You've already got that covered. At this point you should just kind of be fine-tuning your design, and actually really you should have already turned it in and just testing it, and then just fine-tuning it as you need at your schools in order to do that. Now I know a lot of people are still working on their 3D print model. Now, you should know that if you are working on your 3D print model, you should know that there are still issues. And I've gone back with a couple of schools who have turned in who have submitted their 3D print files. You should know that there still are issues, or you should know that I'm still seeing the same issues with the 3D print designs across the board. And I'm going to go ahead and cover those same issues. So one of the issues is that 3D models, the models are flat. A lot of times I'll email you back and say, hey, your model is still has flat walls. It doesn't have 3D walls. What do I mean by that? Well, it's okay to have flat walls so long as the model is enclosed, because what that means to the 3D printer is that, okay, well, it's making a 3D solid shape. If you have, for example, this any of these shapes up here, let's say, for example, the box on the, if we're looking at that white picture at the top. If you have a box, you have, let's see, a cube has what is it? Sorry, it has 6 sides, correct? The cube has 6 sides, which means it's made out of 6 flat walls. But those 6 flat walls together, on an put together on an X, Y, and Z angle, will give you a box because it's closed. So if you have walls, like for example in the picture of the triangular prism at the bottom, below all of those different yellow shapes, the gray triangle shape down here. If you have a gray box like this, and you want it to be like a cubby, or like a cup or something, like a triangular cup where you can put things in it, that's not going to work because those walls are flat. It's an open solid, meaning that if we were to put another triangular face on top of this here, where there's an opening, number one, it wouldn't be like a cup anymore, right? You wouldn't be able to put things in it. But number two, it would be a closed object, because now you have all the walls making one solid object. If you wanted to make this a solid object and you want to be able to print it as is, so that you can put stuff in it, you have to make sure that the walls, this wall, like this wall here, and then this gray wall here that you can barely see because of the angle, you have to make sure that those are 3D walls. And even this wall down here as well, the floor wall, you have to make sure that those are 3D. What do I mean by that? Well, if you look, this is a very thin sheet, right? It's like putting pieces of papers next to each other. That's not going to be able to print. You need to be able to add depth to it. And what do I, you hear me say that a lot. You need to add depth to it. What does that mean? Well, that means that this section here, this line that I'm following, has to be thicker. I guess if that makes any sense. It has to be some kind of depth to it. So essentially, you can make one rectangular prism here, another rectangular prism here, this wall to be another rectangular prism, and then this wall to be just a really, really thin triangular prism. Now you have 3 rectangular prisms, which are walls that have depth, and a triangular prism, which is a floor that has depth, put together to make one solid shape. This will not print, but if you add depth to those walls, it will. Now, how do you do that? Well, one of the ways to do it is to create a shape on top of those and use the push-pull tool to extend it. The push and pull tool really is going to be your friend. If you still don't understand what I'm trying to say, then go on YouTube and look it up. Look up tutorials on how to add depth into 3D models on Google SketchUp. And there's tons of them. There's tons of videos that show you how to add depth. Don't wait till the last minute to do it. In fact, actually, at this point, you really can't wait till the last minute to do it because, you know, the submission has passed. But don't wait till the day of the competition or before the day of the competition to try to print and have your products done, especially if you're sending them over to us so that we can print them for you, because we're not going to have time to print all of the 3D submission models the day before the competition, or even now. Really, we don't really have a lot of time left to print the 3D models and then ship them out. So again, another one of the issues is just having unnecessary internal geometry. Now, I will say I haven't seen a lot of this issue before. I mean, I haven't seen a lot of this issue in any of the submissions that have come my way. But it's just something to keep in mind. You know, if you're going through and you're still making edits to your project, just make sure that you don't have those unnecessary geometries inside. I haven't seen that problem yet, but it's just something to keep in mind. So finally, I guess, if you're still having issues understanding what it is that I'm saying, you can use other software to create your 3D print model. One of the most popular 3D modeling software would be Tinkercad, sorry. And you know, if you just go to Google and type Tinkercad by you'll be able to find a website that looks, you know, like the picture at the bottom there, and be able to download like a starting trial. Actually, I believe it's free, so all you have to do is create an account, but it's really simple and it's really painless. All you need is an email address. You just set up the account, and it's a web-based tool. Now, all I need from you guys is a .stl file, and then I'll be able to print it for you. This is pretty much last minute. If you're still making edits right now, just know that you have very limited time in it, which is, you know, what I'm going to get to now. But before that, if you're still unsure whether it would print or not, you can always just check it. If you go to Google and type "will it print," and then just search it, you can go to the first website, which is, you know, www.willitprint3d.com, and then the website looks exactly like the picture there. All you have to do is just hit get started, and, you know, it'll ask you to load your file, and it'll actually generate the what it would look like if it were to 3D print. If your file looks really weird, like the walls are invisible, or the walls, if you turn it around and some of the walls disappear and that kind of thing, that's because your walls they don't have any depth, which is one of those things I was telling you about. Your 3D printer will get confused because you can't print an invisible wall from one side and have the wall be visible from the other side, right? It just doesn't make any sense. The reason that happens is because there's no depth. The printer is saying, well, I know there's some kind of shape here, it's a wall, but, you know, I can't see it. That's what's happening. So, you know, check it there, willit3dprint.com, and if it looks good, if it looks like the shape you want to print, then guess what? It will print. So, moving forward, late submissions. Many of you, as many of you are aware, the deadline has already passed. So at this point, we're no longer taking any new submission models from any school, except if I've already spoken with you and I've already told you, revise your model, which is, very handful of schools, but nonetheless, still, you're still eligible to get your 3D print. I've already shipped out a couple of them to the schools, to some of the schools who have sent me really good working models, and I printed them just fine. I sent them to them, and you should expect to have them before the competition starts. But, or actually, I should say, you should, or you might expect them, or I guess, yeah, you might get them before the competition starts. I'm shipping them right now, and we're shipping them to get to you as soon as possible. But I can't guarantee that you're going to get them anymore, because this is super last minute. The deadline to submit your files was the 6th, and a lot of you have sent them in before, or some of them have even sent them before. But I've sent you back. Emails or requests to fix it, and have either not heard from you yet, or have you know, have, you know, just recently started getting the 3D models from you guys. I'm gonna, you know, I'm gonna try to print all the ones that you guys have sent back, but just know that I'm only gonna print, you know, so if I've told you to revise it and you send it back to me, I'm only gonna print the one version of that you have sent back to me. Or I'm sorry, I guess I should say, I'm only gonna print the most recently updated version of your file. So if it still has problems, then you know, I can't print it, and you know, unfortunately, then you're just gonna have to go without a 3D print the day of the competition, because at this point there is no time to print and ship, especially if you're one of our Detroit schools. I can't guarantee that we'll get there on time, you know, as it is right now. I can go ahead and print and ship, but I can't guarantee that it'll get there the day of the competition. So that being said, we look forward to seeing, you know, what you guys create for the Mobile Tech Challenge. You know, the 3D print is part of the Mobile Tech Challenge, but not necessarily the entire Mobile Tech Challenge. Some of the schools might not need a 3D print portion of the Mobile Tech Challenge. However, there is points deducted for not having a 3D print, but not all of the points. It's just a fraction of them. So you still can get a really good grade on your Mobile Tech Challenge. But we would love to see everybody incorporate a 3D print for a 3D print thing into their Mobile Tech Challenge. So, you know, that being said, go ahead and keep sharing all your images, and you know, you keep posting and staying engaged with the system community on System Break. We'd like to see what you guys are working on, and we also like to choose a student ambassador. And the way we do that is we choose them based off of the level of activity on System Break. So if you're more involved with System Break, the more you're more likely to get the top ambassador top ambassador trophy for your school. So other than that, you know, thanks again for joining me. My name is Orlando Benitez. Like I said, if you still have any further questions, go ahead and email me at media@system.org. But other than that, I will see you the day of the competition. Good luck, guys. Hello everyone, my name is Orlando Benitez with the final March 28, 2015 Saturday workshop. So, by now you guys already know me. My name is Orlando Benitez, and I've been your trainer for Bristol Bots so far. Like I said, this is cycle 7, March 28th, and it is our final cycle before the competition, in which you should know Detroit is on April 11th. And the Southeast competition in Houston, Texas is happening on April the 18th. So at this point, you should already finalize your projects. So we're pretty much going to go over the, fine tuning, tweaking little things, very, very simple little things. Things like, adding a little bit extra glue to certain parts so that your robot doesn't fall apart, or just making sure that they're sturdy. But I'd like to review again the field, just so that you guys know what's expected. Again, this is an image of the robotics field for the Bristol Bots. Like I said, the day of the competition, it won't be solid red as you see here. The pieces of wood will actually be colored red and blue to distinguish the two different teams that are competing with each other. There will also be wood kind of where the red is. It'll be wood color. So if you can imagine, just inverting the red and the wood color here in this image, except one side has blue, one side has red. But other than that, it's the same design. You'll be starting your Bristol Bots at the top as normal, and then you will let the robots go and let them finish complete the finish line, or not finish the finish line, depending on your design, as described before. Again, I'd like to go over the concept of the field. As you know, when you're dealing with pipelines, you have to be able to clean them out. Again, organizations and like Shell or oil organizations invest a lot of money into making sure that these pipes are placed and can last a long time. Recently, we've had a lot of issues with oil pipes spilling on the ocean, and that's because they're either not maintained well or they weren't built well. Well, this is kind of the concept behind oil rigs, or I'm sorry, behind the Bristol Bot field. Whenever you make a pipeline, you have to make sure you clean it using these things called pigs. As you can see in the picture at the top right side of the screen there. The pigs, as they call them, are used to, they're fed through the pipe, and they're used to kind of clean out the gunk, or even so much as to collect information about the pipeline itself, whether that be pressure in certain areas, or if there's a leak or something. There's different pigs for different things, but for the most part, pigs are used to generally just maintain the pipe. Now, that's the idea behind the Bristol Bots. The two sides of the field represent a pipe. That's why they're long. And the Bristol Bots themselves represent a pig. I thought it'd be kind of cute if, or I think it would be kind of cute if somebody shows up with a pig, like the animal, with their Bristol Bot design to look like the animal pig. That would be funny. But anywho, the pipeline, the robotics field represents the pipeline, and all the obstacles represents the obstacles that normally a pig would have to go through when feeding to a pipe. So that's the idea there. Now, again, these are some pictures of some of the Bristol Bots that you guys will be using. These are examples of what you can use to customize your Bristol Bots to look like. These are the Bristol Bots that we ship in the packages. So, feel free to take some ideas from here, but also be creative, make it your own. And at the same time, like I said before, make sure that your design, which should already be finalized, is good enough for the field, that you'll be able to practice on the field without all your add-ons getting in the way. Now, if you're participating in the Bristol, in the Bristol Bot Robotics Challenge, You will notice that in your packet, you receive one of these little claws, as you can see the kids using in the pictures, or if you want a better glimpse of what it looks like, you can take a look at the far right picture. That claw is used to lower your Bristol bots onto the field. You'll have to lower the Bristol bots onto the start of the line one by one when the timer starts. If you want, you can do more than one at a time. However, I don't recommend you do that because you won't be able to get a good grip on them. And if you have a really cool, intricate design on your robot, you won't want to mess it up, right? Especially if that design is helping you or helping your robot stay on the field. So, finally, I'm going to go ahead and finish this. This was a bit of a short PowerPoint. And a lot of that is due to the fact that everything should already be done. You're just doing some really fine tuning at this point. There should be no reason why you are barely starting on your Bristol bots, or you haven't gotten enough practice on them at this point, because we're only a week away from the competition, and in some cases for you guys in the Southeast, 2 weeks away from the competition. So we're getting down to the wire, and that's why this presentation has been so short. We have to there's no need to go over how to build it or any more tips, because at this point it should be done. But anyways, like I said, we're still looking for a top ambassador, and we always pick our top ambassadors based off their level of interactive, or our level of involvement on CSTEM Break. So make sure you get on CSTEM Break and start uploading your images. Show us pictures of you getting ready for the competition. Show us pictures of your school getting excited to compete. We have had a lot of students submit a lot of content. Whether that be pictures, blog posting, comments. We've had tons of students who submitted even like video tutorials to help everybody else with their projects, and I thought that was pretty amazing. So definitely keep doing those type of things. You'll want to be able to take home a top ambassador trophy home. So it's not too late. We're still looking for something. Thank you again for joining me, and I will see you the day of the competition. I look forward to seeing what you guys have invented, and best of luck to all of the teams, and I will see you then. Hello, everyone, and welcome to the March 28th Saturday workshop for sculpture. I've covered the last couple of Saturday workshops for sculpture. My name is Orlando Benitez, for those who don't know. I'm also doing the 3D print Saturday workshop, as well as the mobile tech and BristolBot Saturday workshop. So yeah, same guy. If you were, if some of you caught that. So, like I said, this is the final Saturday workshop for Cycle 7. At this point, we are going to be, kind of fine tweaking and finalizing everything. Really, your project should already be done. We're a week away from the competition, and that means that everything should just kind of be done, and you're just making sure that everything is fine-tuned, that everything is glued together, everything's gonna stay put. So you should know this by now, but I'll go ahead and repeat it. So what is the challenge? You're going to design a functional endangered sea turtle sculpture that represents the American energy renaissance and how improving the nation's infrastructure can help the United States retain its energy independence. Students will design and create a geometrical sculpture of an endangered sea turtle in the form of a source of light. And again, I've already gone through and explained what that means, but I'll go ahead and lightly cover that again on this PowerPoint. So each school's endangered sea turtle sculpture must not exceed 4 feet by 4 feet by 4 feet. 4 feet by 4 feet by 4 feet is really big for a sculpture. Well, I guess if for a sculpture that it's going to fit indoors, that's pretty big. That'll probably come up to like your shoulders or something. But all sculptures must be accompanied with a type 1-page report and a skilled engineer design of their sea turtle on a 8.5 by 11 graph paper. A lot of people, will tend to forget this part because they're so busy building the sculpture. But this part is almost as important as your sculpture. You have to be able to have a typed 1-page report of your sculpture, and a scale design of the sea turtle sculpture on an 8.5 by 11 graph paper. Yeah, your judges are gonna want to know your inspiration behind it and see your design, the design process behind it. So finally, to create your sculpture color, your final sculpture must not use discarded or found your sculpture must use discarded or found materials or recycled materials, in other words, of the same medium. So you're not allowed to use paint to paint your sculpture. You have to use the color of the material to be able to give your color, your sculpture color. And that sounds harder than it really is. I've gone ahead and showed you pictures in the past of what that looks like, and it doesn't have to be neatly painted. It doesn't have to be filled in within the light. It just has to be what you want it to be, right? And I know that kind of doesn't make any sense, but just make sure that make sure that you're satisfied with the color that you had given it. But again, like I said, you're not allowed to use paint for your sea turtle sculpture. You will be docked off a lot of points for that. Moving on. So form of a source of light. Now, I said I was going to touch on this a little bit. I've explained this in the previous PowerPoints, but essentially what this means is try to incorporate a part of your sculpture that gives off some sort of light. This doesn't necessarily mean a light bulb, right? Because that's what everybody usually thinks of when it's light, a light bulb or something, LED lights. That could be it, but just keep it creative. It could be as simple as a little hole in your sculpture where sunlight reflects through, and it gives your sculpture some kind of really cool lighting effect. It's really up to you. Just be creative. One of those the little sculptures on the left are pretty good example of source of light. Those little what do they call those? They're like marbles on those little sculptures. The scorpion and the peacock. They actually they absorb light, so that, when you put them indoors in low lighting, they look like they're glowing, but they're actually just absorbing so much light that it looks like they're giving off light like a light bulb. But they're not really they're not wired or anything. And then again, another good example is the one on the right side where somebody cut a hole in that room on that window, and then let through a little bit of sunlight, and then they put glass mirrors everywhere else so that kind of help reflect that light, that beam of light, creating this kind of shape effect. Now, when I when I'm giving you these examples, I don't necessarily mean make your sculpture look this way. Remember, your sculpture still has to be a sea turtle. So these are just examples of how you can get light and how they're incorporated into sculptures, but your sculptures don't have to be this. In fact, they shouldn't be this. They should be sea turtles. The closest thing that I can think of that will, work with a sea turtle would be the one on the left side with the little creatures. But then again, I could be wrong. I always say, I always get proven wrong every year. Somebody brings like a really amazing sculpture, and it throws me off, like, oh, I didn't even think you can do that, but that works. It meets all the criteria, and it seems super creative, and that's kind of like the reaction that I hope you guys can give the judges. So make sure that you're creative. The more creative, the better. Just make sure it meets the criteria as well. So I've said this before, it doesn't have to be super complex. Some simplicity is always the best, especially nowadays. Everything is so quick and fast that sometimes a very simple message on a very simple but powerful sculpture can be the difference between winning and losing some point. So don't try to go over the top with your sculpture. You definitely can, but just make sure that you stay within the boundaries of 4 by 4 by 4 feet. And it's really all about the message, which is why the one type paper and the design behind it is really important. Your judges want to see the story behind your sculpture. Why did you design it a certain way? Why did you choose your source of light to be a specific thing? You want to be able to tell that story, because sometimes telling a story is more powerful than the sculpture itself. I mean, you've seen stories of people who sell paintings who, not too long ago, I was on Yahoo and I read somewhere, I know I read somewhere that an artist sold pretty much nothing. There was nothing on the wall. It was empty. It was just, like a gallery, but there was nothing on the wall, and they said it was invisible art. They sold each piece of invisible art, which was nothing, for about $5,000 each. So, sometimes it's all about, sometimes it's better to be able to explain yourself than the actual product itself. It's just the story behind it. So, if he can sell nothing for $5,000 a piece, then I'm pretty sure you guys can sell a beautiful sculpture, to your judges to be able to get, a really good score. Now, again, like I said, don't forget to explain. You need a one type report and a scaled engineering design of your sea turtle sculpture on an 8.5 by 11 graph paper. Show us your design process. How did you come about the finished product? We want to know the logic behind it, right? And I believe there are points associated with all of this as well. So don't forget it. It's really important. Now, in the past, I've showed examples of of sculptures, but they don't necessarily show sculptures from the day of the competition. So I thought I'd give you some examples of some of our previous sculptures from previous years. If you look, the ones on the left, there's a whole bunch of sculptures made out of like tin cans and like spoons, pretty much metal. And you can see each sculpture is made out of recycled materials, and they're all represent a sea turtle. So that kind of gives you an idea of what you can expect the day of the competition. We've had some really amazing projects in the past. So give it all you got, because you will be impressed by other schools' projects, and you don't want to be the school that says, "Oh man, we should have done that. That looks really cool." So here are some, again, these are just examples of previous years from the CSTEM competition. So I'd like to remind everybody that we're still looking for the top ambassador, and the way we pick the top ambassador is by looking at your level of interactivity within CSTEM Break. Get more active on CSTEM Break and upload images, write blogs and post videos, or post like comments on other people's walls. I've seen students post I've seen students post tutorial videos on how to help other students within CSTEM with their 3D prints, and I believe that's helped out a couple of students And I think that's amazing. That's just the community being able to help each other. We have students from Bladensburg, in Maryland, communicating with students here in Houston, Texas, um, and helping each other with their projects. And I thought that was pretty amazing when I saw that. So that kind of interactivity would help. It's going to help you get the top ambassador award the day of the competition. So again, if you guys have any questions, feel free to contact me. My name's Orlando Benitez, and you can email me at media@cstem.org or reach me out through CSTEM Break. I'm pretty good at reaching out to everybody on both. I try to get to everybody, at least once, or I try to give you a reply. So, don't hesitate to contact me if you have any questions, or just, feel free to call at the office. Check our contact page at, our website, cstem.org. But other than that, I look forward to seeing you guys the day of the competition, and I wish you guys luck. So, see you then. Okay, so I paused it.
Good morning, and welcome to the final installment of this C-STEM challenge, Energy Infrastructure, Wind, Oil, and Natural Gas. Today is March the 28th, and we will begin discussing the mural presentation. Everyone is an artist and an engineer. I'm Sarah Trotty, glad to be with you this time again, just before the challenge, and to discuss the last steps in completing the mural for the mural challenge. Most of you know by now my experience, it's all here. I'm retired from the Department of Fine Arts, Visual Art at Texas Southern University. Cycle 7, we finalized the art artifacts solution. Students now will finalize their C-STEM challenge project, coming up with a solution and prepare to compete with other schools. In this cycle, we have talked about the color transfer to the canvas, and we are now doing the final details and finishing touches that make this mural a real masterpiece. And we work with the communication teams to prepare our reports and our presentations. Last cycle, which was cycle 6, we did the sketch and the colors were applied to the prepared color canvas. Prior to that, cycle 5, the best color study was selected for the mural, transferred to paper proportionate to the completed mural size, and finally enlarged on the mural, and color was applied. Students were encouraged to work closely with their researchers and writers to ensure that the narratives of these visual stories and the tone reflect the theme. And all of this could be done through the choice of color and texture and the imagery that was used to reflect this theme of wind, oil, and gas energy infrastructure. Teams are now encouraged to write out and practice discussing the visual expressions reflected in the mural masterpiece and the discoveries made during the research of the theme. Now, in terms of the mural, the canvas, all of that's completed. Some of the murals may be a little smaller than others because of the way they are hemmed. That's not a problem. Some murals may have a 2-inch border all around the front. That's acceptable as well. We won't penalize anyone for those slight variations. Now let's talk about these teams, because this is where the teamwork really comes into play. This last leg of the challenge. The mural construction team assembled and prepared the muslin material for canvas. The mural research team did the research. They researched Dr. Biggers, they researched Mary Ogle and their inspiration paintings, Spring Renewal and Sea Turtle over Atlantis. They also looked at those stylistic influences. They collected images of water, oil, and gas infrastructures for use in the composition by the artist team at some point. The theme research team did the research of how wind, oil, and gas are generated, and how they generate energy and the infrastructure that supports these resources. And so with their understanding and knowledge of that, they're able to convey this information now to the remainder of the team. The art design team took everything that was presented, all the research, all the images that were found by the earlier teams, and put together sketches to bring this into a composition that told the story of wind, oil, and gas infrastructures. And so now they are ready to do the final details on the mural. The writing and presentation team has taken a look, or should have at this point, if they haven't done so, they should begin to summarize the research and the work that's generated by all these previous teams, both visual, oral, and written, and come up with a story as well as an oral presentation, being prepared to answer any questions that might be asked. Now, I've talked about what we need to do in general. Let's look at the theme research team again. They should share these discoveries that they've made, looking at the past, current, and future plans of oil, wind, and gas infrastructures. And they should also be clear about their own feelings and responses to what they found and convey this information. The mural construction team should share what they've learned in constructing the mural itself and what they learned about the historical and current use of murals, as well as the artists who are inspiration artists. So I suggest you go back and take a look at that review. The artist design team, going beyond what was said earlier, will share their advances, their experiences in utilizing this information, how they brought everything together, how they generate the compositions, and how they came up with the final mural that was painted, their masterpiece. The writing and presentation teams now should relate their understanding of each of the other team's findings and work with them and help them translate this information for the mural story and the oral interview. This is interactive, so it's not just the writing and presentations team final story and oral interview, but all that information that they gleaned from their other team members. Now, once this is done, we have a sound story that talks about this whole aspect of creating the mural and what murals mean and how they utilize the research and the importance of that research. And we're now ready to also know enough about this to be on our feet about the work of Mary Ogle, Turtle over Atlantis, Sea Turtle rather over Atlantis, and John Biggers. So you can take a look at his Spring Renewal and her work and use these to help tell the story. Also, the teams were reminded at every step to include the sea stem characters, Slippery, Sprout, and Squirt. These characters help to narrate these stories in terms of the mural itself, just as our writers and our presenters are now going to be the spokesperson. They, in a sense, were the spokesperson. You do want to remember as well, if you haven't done so, that a turtle should be a very important part of your mural, because the turtles themselves have been a part of the Sea STEM program all along, and they help us to understand the importance of these resources for their own survival. I put, again, color enhancement, because at this point, if there's any detail or any changes to be made or any strengthening of the colors, this is when you want to do this for the mural artist team. And of course, the writers and the presenters, the oral presenters, are going to note what was done in the last few stages. The mural artists have worked closely. They understood all the narratives. And now, if color is needed to give a punch or stronger presence to the mural, they're going to add little details, little sparks of color to do this. We talked about how colors can help to establish mood. You certainly should be asking yourself, does this work? This color wheel is in again for you to take a look at the colors that can be used to help make the mural very strong. You should review this so you understand color in case The presenters are asked about how color was used and how they can work to make these kinds of presentations strong. Be ready to do that. This link, again, will give you many, many examples of mixing colors. So I suggest that you take a look at the link and include it in your work. This further enhancement of the color wheel shows how you can change the values, the color itself, make it lighter with a tint of white, create a tone by adding a darker color or gray, and a shade by adding black. So you have to understand color before you begin mixing any of your basic materials. And this link again for your review carries you back to presentations, many of which you can select to help you understand how to use the materials that we have.
You need a website. Why not do it yourself? With Wix, you can create your own professional website that looks stunning. There are hundreds of designer-made templates to get started. Whether you're a small business owner or an artist, we've got something for you. Customize anything to get a site that's completely original. Just like that, you've got your own.
All right, we'll just keep moving, trying to understand how colors work and how we respond to them emotionally, whether it is a functional use of color or sensory social use of color, which shows our attitudes about the things that are around us. I did leave in this slide, which helps you to understand the psychology of color and the basic color principles, that they can carry meanings. They can be based on learned or innate understanding of meaning. It helps us to look at how things are responded to in an instance, and when color is present, how it motivates our behavior. So color is important. And I left this chart in, which shows you some aspects of what traditionally color has meant. And if you want to show some of these qualities, you can keep that in mind. For example, happiness or sincerity, lighter colors help to convey that. Green is usually like nature, shows good taste. So just keep some of those things in mind. This slide showed you how to mix the oil pastels. And so there were a couple of color mixing pastels videos for you to take a look at. And of course, if you want to go back and review this and review how to use the oil pastels in your final piece, whether the same thing with the oil paints, you're encouraged to do so. So oil pastels, and the same thing with acrylic paints. And this particular link helped you to do that. So we'll move on to the next part. Again, you need to evaluate not only the color study, but your complete presentation of the mural. But I'll mention again, the same steps used to evaluate the color study are now used to evaluate the final mural presentation, the mural itself. So you want to ask yourself these questions. Are the objectives that form the basis of your design in connection with the theme evident? We need to see that. We need to see that your design reflects the theme. Is your team satisfied with this composition, the colors selected, and its overall presentation? Does your final composition reflect what your team has learned about the theme? Do the images and colors your team has selected help personify or give meaning to the theme? In your team's color study, or in the final piece, we should say, did you focus your attention on the major points and the objects with placement or color or value or size to draw our attention? Do the images in the color study work together to convey the team's message? Do the other images help to support those images? Is the craftsmanship reflective of your team's best work? Everybody worked together to make sure that edges are nicely worked, that paints look like there are oil pastels are where they should be and not just kind of half applied or left unfinished. When your team's mural is reviewed by others, do they get the message? Are they inspired to discuss this? Have you even taken the chance to invite people who aren't a part of this process to come in and talk with you about what you've done? If not, I suggest that you do so. I left in this information for the grid, but by now everyone should have enlarged their mural. And I left in what the pieces look like before you put them together for both the elementary and previously the secondary school. We talked again about transferring these images. Do want you to remember these characters, so take a look at them again. Sprout, Squirt, and Slippery. Take a look at Sprout with his energy as he seems to always be moving and talking as he observes what's going on. Take a look at Squirt as he is communicating and talking with us. And take a look at Slippery, not missing one detail, looking very closely to what's there. They're going to help you tell this story. So practice drawing them. These sketches of how to draw them are included again to make sure if you left them out of your final mural, this is the time to go back and add them. Remember to use your resources to do your background information. And of course, these are in just because it shows the process of making the mural. I'm going to skip some of that right now because everybody should have completed theirs. I want you to look again, in case you've forgotten, at the inspirational piece by Dr. John Bigger, Spring Renewal. Look at the geometric patterns. Remember, not only should you include some turtles, you should also look at the geometric patterns in the work, but your background should be reflective of the wind, oil, and gas infrastructure that you studied. Those should be your composition. The sacred geometry helps you to learn how to break these images up once you've selected them into final patterns. And I'll just put this one in again, just because it shows the steps of using geometry, how you can build your image from basic tools and geometric patterns. I'm going to pass that one. Let's always remember to look around us for inspiration. The patterns that are there. Your patterns don't necessarily have to be germane to the objects themselves. You can actually take a simple windmill and create a pattern on it, like this peacock's feathers, but make it interesting. Show how energy is generated through these sources. Don't forget that you should have talked to professionals and learned more about this energy. Energy is such an important part of the national discussion these days. Ways to make it work better, and certainly ways to obtain the oil and gas, whether it's through resources like wind or for finding other ways to get to the oil and gas that we have in this country. These examples are still there for you to take a look at. And I just want to say to you that we have enjoyed communicating with you about this year's theme, wind, oil, and gas infrastructure. We look forward to your murals that you've created, and Look forward to seeing you. Thanks for your participation. I'm available now to answer any questions that you have, chat with you. But I want you to also remember that coming up very soon, the Midwest Challenge is April the 11th in Detroit, Michigan, and the Southeast Challenge is April 18th in Houston, Texas. Thank you so much. Look forward to seeing you.
Good afternoon and welcome to the Saturday, March 28th training for the documentary filmmaking. And this particular training is finalizing the artifact solution. We're in cycle 7. So students will finalize their C-STEM challenge project solution and prepare to compete. So how will we relate that to film is we will discuss how do you finalize your film. Last we spoke, we discussed editing. Now you should have chosen your editor and the editing process either has begun or it is now in the rough draft final stages. So this time we will discuss finalizing the rough cut and where you can locate stock footage for fillers. So finalizing the rough cut. You want to review the rough cut first for clarity. You want to know, is the story and message clear? Are the transitions smooth from shot to shot or scene to scene? Are all text words and spelled correctly? Any graphics or stock footage needed to create fillers for dead space and dialogue? So you want to make sure when you're reviewing your rough cut that you're looking for these things. And here's some questions that you could ask yourself, or you can also get someone close to you or others to view this and have them, when I say view this, view the rough cut and have them ask the following 8 questions. Do you get the message of the video? What would you say the video's theme is? What interviews do you feel connected with the story of the film? Did the video feel the right length or did it drag on? Which parts were unclear or puzzling? Which part felt slow? Were there any parts where you felt that the story backtracked or jumped forward? And did the music match the scene? So what I did for you guys today, I have a short documentary, it's 4 minutes long, working on an oil rig, and I would like for you all to answer the following 8 questions along with me. I also answered them in my opinion, but while you're watching this, keep these 8 questions in mind. So let's take a look.
My name is Ben Pomford. I'm the Deputy Asset Manager for International Jackups at Maersk Drilling. I am part of a team managing 6 oil rigs around the world. I often visit the rigs to ensure a smooth communication between shore and offshore. Today I am going out on a visit to the Maersk Resolute, a 350-foot jackup drilling rig in the North Sea. I've worked for Maersk Drilling for 22 years, and 3 years ago, I was a senior tool pusher on board a rig similar to this. The Resolute works in water depths up to 350 feet and can accommodate up to 120 people. It is one of the most advanced rigs in the world and highly automated. Hello, Michael. Hi, Ben. Can I have a good look around the rig, especially the underbalanced drilling, that everyone in town's interested. So I'd like to walk right around the rig. The rig is capable of drilling up to a depth of 30,000 feet, and this gives us the ability to drill high-angle wells and enter the reservoir horizontally, giving much better results for the clients. The driller's cabin is the heart of the operation. This is where the drilling and the search for oil and gas takes place. You can clearly see the new instrumentation, machinery, 2 cyber-based chairs, and the advanced equipment on the drill floor.
Okay, Johnny.
I like being offshore. When I was offshore full-time, I really enjoyed the intensity of the job. When we're on the rig, focus is on the work. It's like no other place I have worked before. A lot of effort has been put into making this rig one of the most efficient and innovative rigs in the world and in our fleet. The way the accommodation is built around the front leg enhances the living conditions on board the rig. Being away from home for long periods of time has its challenges, but this helps to bond the crew together as they work, eat and relax as a team. What I like about offshore work is the clear division between work days on and time off. And when I'm ashore, I can really enjoy being with my family and my friends. When I'm offshore, I am there to work. That gives me the ability to focus better and also to get the job done. Safety is also an extremely important issue. You start each day with a safety meeting. This is to make sure everybody is aware of what's happening and then they can focus on the job safely. My visit went well. I can return ashore knowing that the rig is in safe hands. As part of a large drilling company, I try to do my best to ensure that drilling is done in the most safe, efficient, and environmentally sound way. Drilling projects are more and more complex as the search for oil and gas in harsh environments has become more common. Therefore, a constant emphasis on innovation and technology has to be in place.
Okay, so here are my answers to the 8 questions. Now, I may have a little skewed view of it because I've been editing rig videos all week. However, while I was watching it, the part where do you get the message of the video? Yes, I did. I don't know if you guys did, but the message that I got from it was that it was the oil rig operation and experience offshore. That I took from that video. That's what they wanted the audience to know about. What would you say the theme is? Life on the rig. Now, for many of you, it may be the reverse. You may think that the message is life on the rig, and you may say that the theme is the operation and experience of offshore. But either way, if it switched, it's great because that is the message that they probably wanted to convey. What interviews do you feel connected with the story? Because we had one interview person, I think he did well. He told the story very well. Did the video feel the right length and did it drag on? I thought it was the right length, but in my opinion as well, because I've been looking at rig videos all week, I didn't know if I wanted to continue to watch it. But for a person first time watching something like that, they may have enjoyed it. And it may be a great experience for them to see how this person is at this rig and the ins and outs of what goes on when you're at a rig. What parts were unclear or puzzling? My only thing was in the middle. I wouldn't have known he was a manager visiting the rig because he started saying, I enjoy working on the rig. So if I would have watched the video, like starting from like maybe 2:07 and just watch that middle part and not the end and not the beginning, I would have just took that he was a rig worker and he was just there explaining the rig and his experience offshore. But I think the point of the video was the experience offshore, so maybe it went over well in that aspect. Which parts felt slow? I think it flowed fairly well. You guys may think differently. Were there any parts where you felt the story backtracked or jumped forward? If I had to choose anything, which I really didn't think there were anything, but it was maybe the part where he mentioned his family. But I think that aided in how he was trying to say that when they're away from their family, they connect to each other as if they are family. And did the music match the scene? Yeah, it did. It was very upbeat. It was great music. And if you guys want to send me your question and answers just for fun, I will read them and we could discuss them later if you want to email them to me. So let's go on to the next part. So where can you locate stock footage? Now, in previous courses, we discussed stock footage, and one great place to find stock footage is the following link, and I will go there shortly. And once you pull up the link, you can go to industrial, because that's where the oil and gas footage will be. And you can use this particular footage once you pay for it, because you're not using your film for purchase or receiving money. You can definitely use this in your documentary. So let's take a look at the stock footage site for a second, so you can see how it's maneuvered. So once you go, you can create After Effects files and motion graphics. They're just strictly animations. Like if you want to start your film off with something, let's go to some After Effects files and see if they have anything with rigs. And let's see. And I've used this site on numerous occasions. And let's just see one animation here. And then I'll go to a industrial one. My system is really slow, so give it 1 second. Okay, maybe it's not gonna pop up for us. Alrighty. It may not pop up for us, but okay, let's go to stock footage. So you'll see, and I went to industrial, so you'll know that's what these things, where they are for the oil and gas and natural gas. So here's some stock footage you guys could use, and their prices are on the side. And also, if you go to the very bottom, you'll see that there's more. You have so many to choose from, so you can browse at your leisure. And I don't think any of these are going to play. I'm just going to try one more just to see if it'll play, but I don't think it's going to play on here. So let's just see what'll happen. Yeah, I don't think it's going to play for us. Yeah. Okay, so, but at your convenience, please go there if you're needing stock footage and or any type of animation that you want to add to your documentary, just to give it an extra of some sort. That will be there for you. Okay, so now let's go into exporting your video and video quality. And there are many formats, each with benefits and limitations. So you want to make sure that your video is formatted in the look that you're going for, and it's in the highest quality possible, depending on what the rules are for the competition. So let's go into our first format, which is the MP4. MPEG-4 video, referred to as H.264. I love this because of the crisp quality that you get, and the compression to it. So it'll compress the size of the video, and you can use it for online streaming. It's really, really great. It's also used and supported by Blu-ray players, handheld gadgets like iPad, PSP, YouTube, and other streaming services, and also TV broadcasting. So I definitely recommend the H.264 when exporting. And again, just know that your editor should know these things and will know, but I always like to know everything. So, okay, here's another one, which is the Advanced Video Codec High Definition. It's a high definition video formatted, developed in collaboration by Sony. Okay, it uses compression based upon H.264 and is a good option for editors that want to export HD quality movies for playback on DVDs. So if you need to put your video on a DVD, definitely go with the AVCHD. That's a lot to say in one take. Sorry. The MOV files, that's normally used with Apple, the QuickTime multimedia format. The components are arranged across multi-tracks. MOV files can be easily edited, often without the need of permanently changing the entire source footage. So that's a great thing. And because of that, like it says here, it's a commonly used format. So that's another option for you guys. The AVI files, a media container that stores nearly any format of audio and video and plays them back simultaneously. It often uses video compression based on an older MPEG-4 or MP4 format. It can be displayed on most computers worldwide. AVI files are okay, but I am very partial to the H.624. The WMV, I'm sure everybody is familiar with that. The format was originally developed for streaming videos over the internet, but the superior quality is again H.264. I think I said it wrong earlier, and it's which is often preferred again by myself. But a key benefit of WMV is that it's supported by a wide range of applications and systems, including Microsoft Xbox 360. So that may be good for the students to want to, maybe if you export something, you may want to export it in two different ways. You may want to export it on DVD. You may want to export it on the H.264 for streaming, and then do it maybe a third for the WMV if they are using the Windows, a laptop or desktop, and they want to view it there. And that's all I have for you guys. So thank you all, and thanks for attending. It's been a great year training, and I will stay connected with you through CSTEM break for the next 15 minutes. And if you have any questions, and if you want to send those questions back to me, again, the 8 questions from the video, you can definitely do that. So please feel free to contact me on my CSTEM break profile. Thank you, and have a great showing for the competition.
Hello, everyone, and welcome to the C-STEM Photography Challenge. My name is Alicia Garcia, representing the Houston Center for Photography in our 7th and final installment of our Saturday workshops. So if you can see, today we are finalizing artifact solution. So in a visual sense, what that means is that we are finishing up and probably making the frame, finishing up creating your solution, and getting ready to compete. So with that, I have 2 helpful things that might be helping your students because we're using different types of cameras. Helpful hints are you might have discovered that some of your students have darker photos. Now, I don't think this is going to be a problem on like little point and shoot cameras, like, you have a little Canon or Nikon, Sony, Pentax, Olympus, little point and shoots that, you keep in your pocket. Don't have a problem with those. When cameras like that run in auto, the flash automatically pops up when things are too dark. But on cell phones, sometimes people disable the flash. So I've noticed that if your child is using their parent's cell phone and your students just don't really know how to turn that on, it's a good recommendation that tell parents to put the automatic flash setting on their camera. I mean, not just camera, their cell phone. So I would take the photo on the right that we're looking at any day of the week over the photo on the left, especially because sometimes when you print photos out, they're just a hair darker than what we see on a computer screen, or especially from what we see on our phone, on computer screen, anything like that. The biggest reason is because when we look at an image on a computer screen or cell phone, that image is lit up from light from behind. So that bright image is lit with all these little lights. On paper, there are no lights to help that image shine. So we have to make sure we have a nice bright image because it's not backlit. Of course, flashes do better when they're closer to your subject. So we're doing close-up photography. We should not have an issue of a flash being outside this far away, where although it does help the girl on the right, it doesn't help her for our type of challenge. So make sure that the framing, and I mean that in a visual reference, the way we look at the photographs and how we're taking them is done correctly. So we are finalizing. Notice I didn't say that we're absolutely done. Finalizing means we're in the home stretch. And we are preparing for competition so that we will all meet at George R. Brown. So, quick refresher. What's getting us to George R. Brown with hopefully an array of different ideas from other schools would be that we went outside because the weather is actually starting to be quite beautiful. And I'm speaking from Houston, Texas. If you are from other cities in Texas and in the nation, you might not have had the birth of beautiful weather like we just did, but we're finally getting to what we call spring skies. So skies are actually becoming blue instead of being that flat gray or washed out color. So I'm hoping that you were able to get outside of your school. Maybe it wasn't a field trip, but it was just outside. And that your parents had some participation and had your students use cell phones, so that it brings us to this democratic process of having the parents send you emails of their favorite photos, that you were able with your school district email to be the filter and collect images to then talk to your students about. We're beyond the image making part at this point. We've made the photos. We as a team, as a group, wherever you are, somehow voted on which photos were going to be the ones that you moved forward with. Now, just as your parents were equally involved in taking photos, delivering the photos to you, parents should equally be involved in the framing process. So how do we create the frame? Number one, we have really young students. If I had older elementary school all the way to high school students, I would be asking the students to gather their own materials. Here, I stress that the parents should help gather the materials that we can make the frame with. This prevents anyone trying to go and find things outside that either are not safe or maybe they are like a health issue. Or honestly, it could be that that's not yours and you shouldn't take it. Secondly, We want to show everyone in your class the favorite examples, because you need to explain that not all materials are very good when they're glued together. We're dealing with really young students, so in other challenges we stress we should only be using hot glue or super glue when you're in high school. That you're putting your things together. If you as a teacher, you can staple things, but better yet, we're using Elmer's glue and stick glue, things that are incredibly safe and are water soluble. So again, we get the wheels turning by bringing in all those examples. You can, as a teacher, decide one of two things, that you are going to be the filter and make some assessments of what's going to be shown as the quote-unquote favorites, or you can bring all of the materials to the table, of which then everyone will pick and choose which designs and materials get to go into that competition. I find that voting is all good and fun, but sometimes people get their feelings hurt, so neutral and being blind voting is actually incredibly important. So, reminder, you can use color systems, we can use Post-it notes that then create an array of colors. We could vote on all sorts of things. Do we want our frame to be paper? Do we want our frame to be made out of things we found outside by our photograph? And maybe it's that there are candy wrappers and there were lots of plastic bottles because people don't recycle. Something that connects to the location of where you were. And you vote on it. You're like, yay, this one got more green Post-it notes than this other example. But the idea is we can vote on color. We could vote on material. We could vote on if we were going to cut something up and collage it, or if it's just going to be glued. There's so many things to vote on besides a general, is this good or is this bad? There are many elements that make up why we like something. And why do you like a certain food? It's not just because of the way it tastes. It might be the texture, could be the smell, it could be that it reminds you of something. There's never a simple yes or no answer, and we should teach that for creativity to your students at a very early age if we can. When we talk about the frame, if you're ever concerned that you're deviating too much from the prompt, it's that we're doing close-up, not to be confused with extreme close-up photography. So close-up would be from my shoulders to the top of my head. Like that's a close-up in ratio to me. Extreme close-up would be just my eyes, or just my mouth, just my forehead. So you're making close-up photography of an area where modernized wind turbines can be placed to generate clean and renewable energy. So places. Be very careful that you do not confuse close-up with landscape photography, because that will impact the way we read your photographs. And of course, we're using at maximum an 8x10. Of course, you can make photos that are smaller if you feel like you need to build a large frame within the dimensions that we have listed. So we can briefly talk about the frame. Realize that we're here to DIY the frames, right? Do it yourself, construct something at home, not repurpose an old frame. This is not the let's go to a resale shop, let's go to an antique store, let's take the one frame that no one uses, it's in the hallway closet. This is not that moment, because we want to make a frame. What's going to stop me from going somewhere else and realizing that you just got that from Hobby Lobby or Michael's? All you did was take out the glass panel. So be very careful and realize that the glass panel, if removed from a frame, actually takes the structural integrity away from that frame. So what we see here is very easily achieved. And even scarier, in the top right corner, when things fall apart, sometimes there are brads, staples, or nails that are exposed. And we have a really difficult time making sure people don't cut their hands. And here's just another example. The glass is gone and this can happen. So repurposing the 4 arms and legs, you want to call them arms, you call them legs, of your frame is not necessarily the best way. And it takes a lot of creativity completely out of the conversation. Or you decide to leave the glass panel in, and this happens. You break the glass on your way when you're traveling. So let's not do that either. Fair warning, we never travel glass laying down. You should always travel glass vertically. And put some tape in, a little X from corner to corner to make sure that we have some structure. But this would be a nightmare to travel to Georgia Brown if someone actually did decide they wanted to go through with this. One, it's breaking the rules, but at least if you're going to break the rules, don't put your safety into question. Remove the glass. If you really can't find any other way to construct a frame, please remove the glass. I would actually feel better if no one even provided plexiglass, just because it gives the illusion that it could break, because we don't know if it's plastic when we see it. But what I do really enjoy, some of my favorite photos I was able to find, is what we can do with construction paper or cardboard. So cardboard comes in all different thicknesses. So what I'm showing here for you is it's a little thick. But what's really nice about this is you could draw whatever pattern you want. Your group can agree on it and say, oh, that's what we like. And then you can cut away. As long as we're still within the bounds of 8 by 10. If I take a ruler and go around that design, it should be 8 by 10. So this could be a lot of fun, because on the flat brown areas that you see, you can have your whole class say, oh, you know what, we're going to describe all the words and the sounds we heard while we were taking this photo. And then everybody's writing all over it. So we get to see their handwriting, we get to see part of a story. There's a lot of ways to incorporate the flexibility of cardboard. So this is really exciting. But if you notice, I don't know the limitations of your students and their tools. Nobody should be pulling out box cutters or X-Acto blades or think that because they saw mom and dad do it, they should do that here. I bet you're using safety scissors, things that are not very strong, purposefully. So this might not be the best option. Maybe it's cardstock, something that's stronger than paper, and it's not as thick as cardboard. Cardstock comes in, it's a fairly standard stock. But if you're like, I really want cardboard, paper towel and toilet paper rolls tend to have nice, flexible, thin cardboard that you could use a full tube, and you could sandwich the tubes together kind of like Legos and make a structure. And all they need to be connected with could be tape, and then we paint it. Then you do something else with it. There's so many ways that we can make regular everyday household objects fit and work for what we need to do. So think about the idea that we should think about decorating and color choices, and all keeping in mind safety. The last thing I would hope we could avoid would be that people see a traditional frame as opposed to this cardboard frame, and they assume that means that they want to draw or write on it. It's going to have to be like a permanent marker. Like a regular marker wouldn't stay on. We could wipe it right off. With cardboard or anything that's paper-based, it will absorb the ink. So suddenly we're not worried about messing up the photo because we did something last minute. It will absorb the ink. And last thing I'm going to leave you with is please construct your frame and then place the image inside of it. Place the image inside when you're 100% done. Do not do it in the opposite order, because you could accidentally scratch your photograph. You could drop something and dent it, or you're painting or using a marker, you drop it and now you've marked over your photograph. So be very kind and be very nice to your workflow. Make the frame, then put the photo in. Sometimes we don't really think about this anymore because one, people don't really print anymore as much as we did, a few years ago. And two, we always have a pane of glass. So we're not really worried once a photo is in a frame that you're going to damage it. Here, we have to think a little proactively. So please, if you have any questions, contact me either in the chat that's about to happen or via email. We have had a few questions where some schools just wanted to make sure that we from CSTEM knew that their school was not in the photo challenge. If you think that somehow you are included in the wrong thing, please send an email and we will have the proper people respond to that. And thank you very much for your time, and I really do look forward to creative, unique ideas at the George R. Brown this year. Thank you very much.
Hello and welcome to the March 28th Mobile Tech Challenge Saturday Workshop. My name is Orlando Benitez and I'll be covering the last Saturday workshop before the competition. Now, like I said, we are in cycle 7 for the Saturday workshop, and this is our final Saturday workshop before the day of the competition. We have 1 week before the Midwest competition in Detroit. So at this point, students are going to be finalizing their projects and getting ready for the competition. Now I'm going to go ahead and cover the problem for mobile tech, and I'm just going to quickly reiterate what the issue is. You should already know this, but I'll go ahead and just repeat it. So the issue is our technology and infrastructure, right? Dependency on the aging electrical grid and pipeline lead to power failures and interruptions across the nation. We can't depend on our aging technology to do its job anymore. We can repair it as much as we can, but we need to start coming up with creative ways to make sure that we are energy and that the United States is an energy independent country. So that's where we come in, right? The Mobile Tech Challenge. That's what it's all about. The Mobile Tech Challenge requires students to design a solution in which an aspect of their project is 3D printed. Again, that deadline has already passed, and that will, that has been discussed in the 3D print, Saturday workshop that happened earlier today. But like I was saying, the Mobile Tech Challenge is pretty much your team's designing a mobile tech solution that's going to help the energy, the United States be an energy independent, energy independent country through, a better energy infrastructure. So the way you're going to present your projects the day of the competition is through a Shark Tank style way of presentation. Those of you who've seen the show know what I'm talking about. Shark Tank is but those of you who haven't seen Shark Tank, essentially what it is, it's a show where, aspiring entrepreneurs making a business have a presentation in front of a panel of sharks. Now, sharks in this case refers to people who are at the top of the food chain in, the business world. These are people who have established their name and who have, established pretty much big business brands, and have been very successful with doing so. That the reason they're called sharks is because they are up there. They're at the top of the food chain, and in the ocean, nobody messes with the sharks. So that's why that's what they call them, sharks. They're powerful, they're big, they're fearful, but they're also very beautiful and very powerful creatures. And they're that they need to be respected. So that's kind of the idea here. So here's a picture of the show. If you look to the left, there's what we have. They're the panel of judges, or the sharks. And if you look to the right, there's the entrepreneur pitching his idea to the sharks. Now the entrepreneurs come and they pretty much present their projects to the sharks in hopes to get help, either with funding or with anything else, so that they can make their projects come true. In this case, it'll be you guys in front of a panel of sharks. So you guys will be presenting your Mobile Tech Challenge projects, as opposed to what this guy is presenting, which seems to be some kind of sales program. And in hopes that your project gets more points for the competition. I'll repeat what the each of the grade levels have to do, but again, like I said, at this point this should have already been done. You should already know this. You should be nearing your completion. So elementary school students will design a functional accessory that improves the current energy infrastructure in your region. Middle school students will design a functional portable structure that improves the current energy infrastructure in your region. And high school students will design a functional wearable structure that is powered by wind to generate clean and renewable energy. So make sure you, if you didn't already know this, that you are making edits to meet that criteria. Now, before you come to the competition, make sure you confirm a couple things. The first is to make sure that you have confirmed. The first is to make sure that you can. The first is to make sure that you meet all the criteria on the rubric. Check the curriculum. Make sure that you can tick everything in that box so that you can get the most points possible. A lot of people have not turned in 3D print submissions, so that means that for those people, they probably won't meet that criteria. But just make sure that you meet everything else. Also, if you use all the accessories in the kit, this is important because a lot of schools will submit projects that use all of their materials, while some schools submit projects that use some of the materials. But what that means is that you're risking not getting all the extra points or not using all of the material. Make sure that you are using all of your materials at your disposal as efficiently as possible. Trust me, it'll help get you the most points the day of the competition. So, is the presentation inspiring enough? Make sure that your presentation isn't boring, because that's pretty much what it means, right? In this picture, the judges, they seem intrigued. They're listening, but they don't necessarily look like they're having fun. To be honest, the guy presenting doesn't really look like he's having fun either, and it's probably because he's not doing a good job at presenting, and he's probably not going to have his stuff funded. So make sure that you're making your judges happy. Make sure that you're keeping them entertained. So be creative with the way you present. It doesn't have to be like a PowerPoint presentation where you sit up there and read off a screen. Make it as creative as possible. I've seen shows on Shark Tank where people come in and they burst through things, or they break a wall, or they pop out of something. They get pretty creative with the way they present. You're not bound to any kind of you're not bound to any one way of presenting. So be creative. Make sure that it's inspiring. Also, will it convince the judges? So it's one thing to be really crazy and bring fireworks and all that stuff, but don't bring fireworks. It's not allowed. But you know what I mean. It's one thing to be over the top, but it's another thing to stay on topic. Make sure you convince your judges that your product is going to help the the United States be an energy independent country through a better source of energy infrastructure. So make sure that you're being convincing with that. There's no use in being really loud and crazy and extravagant with your presentation if at the end of the day all we got was, well, it's important because we said so. Well, that doesn't really help. Just make sure that you're covering that, because that's arguably more important than the way you present it. Test. There's nothing more embarrassing than showing up the day of the competition and flipping a switch on your project and then nothing happens. Make sure that you test your project. If it's supposed to do something, electrical, or if it's supposed to do something kinetic, make sure that it works before you come to the competition. Because if you flip the switch and then nothing happens, you're going to be sitting up there with the judges looking at you, and you're going to say, well, it worked at home, but it's not working here. That's not really going to help much. They'll be like, well, that's cool. I guess it was supposed to do something cool, but it didn't. And that's not going to impress them, a lot. So that'll dock off some points. So make sure it works. Make sure the key features work. Make sure they pop. Your project is distinguishable from any other project. Don't make it just look like a generic project that everybody else has brought in before you. Make sure it pops. I've seen some pretty creative projects in the past, and you're not limited to what you can do. So creativity really is in your hands, and just make sure you test everything so that it works. Also make sure you test your argument. Go ahead and try it with somebody. Try your speech with somebody else, or your presentation. Sorry, if they're not convinced, then chances are our judges at the day of the competition will not be convinced. So make sure that you test it, and if you are testing it, most of the reactions are, wow, that's really cool. I've never thought about that. Then chances are our judges are going to think the same way. Also improve it. If people are saying, wow, this is really cool, then be thinking, well, how can I make it better? Just make sure that you don't, you know, just make sure that you stay within the boundaries of your criteria. But other than that, you know, thank you for joining me. My name is Orlando Benitez. I look forward to seeing you guys. I look forward to seeing everybody's designs or projects the day of the competition. This is by far probably one of the most exciting competitions, and one that I personally look forward to seeing, or one that I personally look forward to seeing projects be done for the most, because it's technology, right? Who doesn't love technology? So I look forward to seeing you guys at the competition, and good luck to you all.